first example here is dealing with arc length. So if you recall, the formula for arc length is the SOR formula. So it's the arc length S is equal to theta, which is the central angle in radians, times the radius. And one thing to keep in mind here is that the radius and the arc length will always be in the same units, while theta must always be in radians. So this angle must be in radians. So you may have to convert depending on the problem. So if we look at the first example, it's saying find to the nearest tenth the length of the arc, so that's going to be the S, of a circle with a radius of 6 yards and intercepted by a central angle measuring 270 degrees. So this is our theta, but the problem is it's in degrees. So the first thing we're going to have to do is we're going to have to convert 270 degrees into radians. So on your reference sheet, you have the conversion factor. So basically, the way that I think of it is if I'm going from degrees to radians, I'm going to be multiplying by pi over 180 because I'm trying to cancel out the degrees. Otherwise, if you're going the opposite direction, if you're going from radians to degrees, then it's going to be 180 over pi because you're trying to cancel out the radians. So when you do this, in your calculator, all you want to do is do 270 divided by 180. You don't want to put pi in your calculator because if you put pi in your calculator, then you're going to get an irrational number, and we don't want to have that. So basically, we're kind of leaving our answer in terms of pi. So 270 divided by 180, when you reduce that, is going to be 3 over 2. And then we're going to just keep pi. And pi is in the numerator, so I'm going to keep it in the numerator. So 3 pi over 2 radians is the conversion. So then the second step, well, the question asked us to find to the nearest tenth the length of the arc. So that means we're going to be using the SOR formula. So S is going to be theta in radians, which is the angle. So 3 pi over 2 in radians times the radius is 6. And since it says to round to the nearest tenth, that means that you're going to just enter this entire thing in your calculator using pi. So when you do that, so you actually enter pi in the calculator, you're going to get 28.3. And remember, the units always match whatever the radius units are. So since the radius is in yards, the arc length is also in yards for this. And remember, there's a difference between arc measure, which is going to be in degrees, versus the arc length. We're going to use the same length or the same units as the radius. And then the next example on this page is looking at area of a sector. So we have arc length, which is part of the circumference. And then area of a sector is the area of basically a wedge here in the circle. So in this example, in the diagram below of circle O, diameter AB and radii OC and OD are drawn. The length of AB is 12, so that's labeled, and the measure of angle COD is 20 degrees. So COD, this angle here, is 20 degrees. If arc AC is congruent to arc BD, so I'm going to go ahead and mark that. Find the area of sector BOD. So sector BOD, let's actually look at that, is going to be this sector, so BOD. It's this area that we're looking for. So it's the area of that wedge piece. So that means we're going to use the sector area formula, which is basically asking you take the area of a circle, which is pi r squared, and then you're going to multiply it by the fraction of the circle this wedge represents. So what angle divided by the total 360 times pi r squared is really what's going to happen here. So the first thing I really need to focus on if I'm going to be using this formula up top is I need to figure out that central angle. So the central angle of this circle is this angle right here that I'm concerned about because I'm trying to find this blue area. So if you look, since these two arcs are congruent, we know that in a circle, if we have congruent arcs, then the central angles that they cut into are also congruent. So we know that these two angles must be congruent. So let me just write the reason for that. So in a circle, congruent arcs imply congruent central angles. So that's why I know that those angles are congruent. And then if I want to find these two angles, well, I know this entire set of angles is going to be 180 degrees because they form a straight line. So if I do 180 and I subtract off the 20 I have, I'll be left with 160. And then I need to split that evenly between the two congruent angles. So then we end up with 80. So each of those central angles is going to be 80. So then from there, I can go ahead and I can use the formula. So then the next step here is my sector area. And that's just going to be using this formula. So it's going to be the angle, the central angle you have. So it's going to be 80 degrees. The central angle has to be in degrees here since you're dividing by 360. So you might want to make note of that. Must be in degrees. And that's because of the fact that you're dividing by 360 degrees. So 80 degrees out of the 360 is what you're dealing with for the sector, times pi. Radius, we have to find, well, if the whole thing is 12, the diameter, then the radius is going to be 6. So we know it's going to be 6 squared. So I just plug in. It says to leave our answer in terms of pi. Leave your answer in terms of pi means you put everything in your calculator except for pi, and then we're going to write pi in our final answer. So you're going to do 80 over 360 times 36, or 6 squared, and you're going to get 8. And then we're going to keep pi in our final answer. So just make sure that you don't put pi in your calculator. So then whatever the units are, which it doesn't tell us, so I'm just going to write units squared. Because it's an area, it would be whatever the units are squared.